So this video is all about parallel and perpendicular lines. So really quick, if you don't realize, parallel lines are any two lines that do not touch. They have exactly the same slope is what happens. So however much this one rises, it runs the same much as this one rises and runs. So if the slopes of lines are the same or equal, then lines are parallel. So a lot of times you won't just have the lines, you'll have just the equations, and so then you look at the slopes, and if they're exactly the same number, then lines are parallel. Now for perpendicular, you have a line that comes this way and a line that comes this way. They might make right angles to each other. One's positive, the other one's negative as far as the slope goes. If the slopes are opposites, so one's positive, one's negative, and reciprocals, what's a P? Reciprocals, then the lines are perpendicular. Now, just so you know, parallel is, you got the double L, that's the symbol for parallel, and perpendicular, kind of look like the upside down T. It's the right angle on this. We're going to draw the right angle. So an example would be one has a slope of 3 and the other one has the opposite, so negative, and then the reciprocal 1 over 3. So this would be 3 over 1. You flip it. So that's what it means by opposite reciprocal. So sometimes I use like M perpendicular. Or let's say we have a slope of negative 3 over 5. The perpendicular would be a positive 5 over 3. Okay. So that's the basic rules. Let's see some of the examples. So for example A, you want to write the equation of a line that is parallel to this line and passes through this point. The parallel lines have the same slope. So the slope here is 3. So my slope parallel would also be 3, always the same. So what we need to put some in point and slope form is a point and a slope. So we're going to put it into our y minus y1 equals our slope times x minus x1. Again, we always plug in for y1, and x1. So what do we get? Y minus y1 is 1 equals our slope, which is 3, our parallel slope, times x minus our x1, which is 4. Now you'll notice I didn't even use this negative 5 in the problem at all. It is extra information. We don't care. All we care about is the slope. From here, all we got to do is distribute our 3. So y minus y1, or y minus 1 equals 3x minus 12. And then we got to get the y all by itself, so add the 1 over. So our final answer is y equals 3x minus 11. And that is in slope-intercept form. So what we want is we want to write the equation of a line that's got this point and perpendicular to this line. So what we know about perpendicular slopes is the line perpendicular to this is going to have a slope of, well, this is a slope of 5, or negative 5. So the opposite reciprocal would be 1 over 5. So that's the slope we're using. Notice I don't even care about the y-intercept. All I'm taking from this line is the slope. Now, we've got a point and a slope. So what we're going to do is we're going to put it in our point slope form. Y minus y1 equals our slope times x minus x1. Again, we always plug in for y1, m, and x1. So y minus our y1 is 7 equals our slope, which is 1/5, and then x minus a negative 5, so plus 5. From here we distribute. So y minus 7 equals 1/5 x, and this is 5 over 1, so 5 over 5, or 1. And the last step is to bring the 7 over. So y equals 1/5 x plus 8. And that's how we write the equation of a perpendicular line. Alright, example C is a little bit different looking. It doesn't have an equation, but it does have a definite slope. So what do we know about parallel slopes? They're the same. So the slope parallel is going to be 7 over 8. Okay, so from here we're going to plug into our point slope form. Y minus our y1, which is a negative 10, so two negatives make a positive, equals our slope times x minus x1. Okay, distribute, so y plus 10 equals, well, 7/8 x, and then you got to be careful about this. It's not going to be a whole number, so when we distribute this, you can't just type it in your calculator. Other words, ends up being 28/8 reduces to 7/2 if you put a 4 into both top and bottom. All right, the last step we got to do, subtract this 10 over. So y equals 7/8x. Now you can go to decimals if you want to, especially if you want to graph it. It actually would be easier as a decimal. So this decimal is negative 3.5. Minus 10 would be negative 13.5. So you can do that either as the fraction, and the fraction would be 27/2, which then is still the 13.5. But if you want to put this on the graph, it's a lot easier to do the y-intercept as a decimal, but you want to keep your slope as a fraction no matter what, which is a little bit strange to do it this way because you have the mixture between fractions and decimals, but a y-intercept as a decimal is easy and a slope as a fraction is easy. So this is actually probably the most user-friendly way of doing this problem. All right, let's try out D. So we have an equation, and we have a point, and we want it to be perpendicular. So be very careful if you want parallel or perpendicular. So the slope here is negative 5/3. The perpendicular slope would be positive 3/5. So once we pick that out, we discard the 8 entirely, and we got y minus y1, which is a negative 3, equals our slope, 3/5, positive, times x minus x1, which is 9, well, negative 9, so plus 9. So we get y plus 3 equals 3/5x plus, well, not much going to happen here. We're just going to get 27/5. All right? Which, if you want to go decimal, that's fine, but you subtract the 3 over, so minus 3, I think you can see that. And your y equals 3/5x. And then 27/5, that ends up being, what is that, 5.4, I believe. So 5.4 minus 3, and you can just toss this in your calculator if you're not 100% sure. The way I was doing it was 25/5 would be 5, and you get 2/5. Each fifth is 0.2. So that's how I did that in my head. But either way, 5.4 minus 3 would be 2.4, so plus 2.4. Again, just like the last problem, decimals as the y-intercept, as long as they're not repeating crazy decimals, are fine, but fractions for your slope for sure. These questions, whether they're parallel to the x-axis or parallel perpendicular to the y-axis, something like that, I think are actually better with a picture. So what we're going to do is draw what happens. Now remember, this is the x and this is the y-axis. I want to be parallel to the x-axis, and I'm going to go through this point. 1, 2, 3, 4, negative 1, 2, 3. So there's my point. I want to be parallel to the x-axis, so I would be this way. The equation of any horizontal line is always y equals. I picked that as horizontal just based on the picture, and so y equals, well, y equals negative 3. And that's it. That's how you do the problem. So if you want to be parallel to the y-axis, right here, going through the point negative 2, 1, 2, 3, plot your point and draw a line that's parallel to the y-axis. And so I can tell it's a vertical line, so any vertical line is x equals, and what does x equal? Negative 2. So these problems are kind of a mixture of being a little bit easier and a little bit tougher at the same time, because people want to use what we were doing before, and they want to say, okay, well, if I'm parallel to the x-axis, what's my slope? Well, it's actually 0, so you could have done y minus a negative 3 equals our slope of 0 times x minus x1. Well, 0 times all of this is just 0, so y plus 3 equals 0, and you'll get this. That works just fine. But if you're parallel to the y-axis, if you realize it's vertical, my slope's undefined. And we can't really use the point slope form for a undefined slope, so we have to do it this way. We just got a couple more to practice with here. So a perpendicular line y equals negative 3 passing through this. So the first thing I would do is I would draw the line y equals negative 3, and that's down here, right? This is the x-axis and the y-axis. Sometimes when you draw this, it's sometimes hard to tell which one of these two is the x-axis. And we want to go through the point 5, negative 8, 2, 3, 4, 5, down 4, 5, 6, 7, 8. Being precise at the point is not that important, but it is important to tell if I want to be going this way or this way through the point. So I'll be perpendicular to this line, which means I want to come through here like this, meaning I have a vertical line. If you want to be perpendicular to a horizontal line, it better be a vertical line. So a vertical line, always x equals. What is x equals? Well, the only value we have for x. All right, the next one's a little bit more straightforward, but it's kind of tricky as well. So we want to be perpendicular to this line. Negative 5x plus 2y equals here, negative 8. So I need a slope from this. It's not vertical, it's not horizontal, I can't just sketch it out. You actually want to solve this for y. So add the 5x over there. So 2y equals a positive 5x, because it's negative on the left, minus 8. Don't lose this sign. This sign stays with the 8. And then divide by 2. Let me divide everything by 2 instead of the whole thing by 2. Because now my slope is 5 over 2. I want to be perpendicular, so my perpendicular slope would be negative 2 over 5. So that's what I want from this equation. So once I have that, I'm going to then plug in the point slope form. So y minus y1 equals my slope, negative 2 over 5, times x minus x1, which is 3. So from here, plug it in, distribute, and solve for y, and you've got it.